Good evening, kids. Today we are here with number system. नंबर सिस्टम जैसा कि आप जानते हैं, हमने पिछले लेक्चर में कहीं आपको रैशनल और इरेशनल नंबर्स के बारे में जानकारी देना चाहा था। जो रियल नंबर्स हैं उसको हमने दो हिस्सों में बांटा था। तो इसमें अगर हम देखें तो जो रियल नंबर्स हैं वो दो पार्ट में बटा और एक पार्ट हुआ रैशनल नंबर्स और एक हुआ इरेशनल नंबर्स। इरेशनल नंबर्स नाउ बेसिकली नंबर सिस्टम में नंबर्स रियल और इमेजिनरी हो सकता है, बट उस इमेजिनरी नंबर्स को हम इस क्लास में डिस्कस अभी नहीं कर रहे हैं। हमने पहले ही कहा कि उसको हम लोग 11th क्लास के स्कोप में रख रहे हैं। जो रियल नंबर्स है उसको लेकर चल रहे हैं, उसमें रैशनल नंबर्स एक पार्ट है, दूसरा इरेशनल नंबर्स। रैशनल नंबर्स की डेफिनेशन कुछ इस तरह से दे सकते हैं, नंबर्स और रियल नंबर्स which can be expressed in the form of P upon Q, where P and Q both belongs to integer and Q at the same time should not be equal to 0. बोथ P and Q, एक तो नंबर को P अपॉन Q के फॉर्म में एक्सप्रेस कर सकते हैं, दोनों के दोनों P और Q सेट ऑफ इंटीजर्स में से ही आते हैं, जहां Q अदर देन 0 एनी नंबर हो सकता है। ऐसे नंबर्स को हम लोग रैशनल नंबर्स कहते हैं। फॉर एग्जाम्पल्स में अगर हम लें तो आई कैन से 2 अपॉन 3 एक रैशनल नंबर है, 0 अपॉन 5 भी एक रैशनल नंबर है, 3 अपॉन 4 भी एक रैशनल नंबर है, निगेटिव कर दिया, निगेटिव 2 अपॉन 3 भी एक रैशनल नंबर है, etc। ये सब में हम क्या देख रहे हैं, ये ऊपर वाला और नीचे वाला दोनों इंटीजर्स है, और जो डिनोमिनेटर है वो 0 कभी नहीं है। जैसा कि मैंने कहा, Q can never be equal to 0, और all the numbers P upon Q के फॉर्म में हो, P और Q both belongs to integer हो, और नीचे का नंबर अनडिफाइंड ना हो जाए। अगर समथिंग बाय 0 लिखूंगा तो वो अनडिफाइंड हो जाएगा, इसीलिए Q को इन्होंने 0 के अलावा कोई और नंबर लिया है, 0 नहीं लिया है। ये तो हो जाते हैं रैशनल नंबर्स। नाउ इरेशनल नंबर्स के बारे में कहा जा रहा है कि वो नंबर्स which are नॉन रिपीटिंग, अगर उसे डेसिमल में एक्सप्रेस करूंगा, नॉन रिपीटिंग एंड नॉन टर्मिनेटिंग, neither it will terminate, numbers which are non-repeating, neither it will terminate nor it will repeat, it will keep on continuously going on। डेसिमल सिस्टम में अगर हम इसे एक्सप्रेस करेंगे तो ये देखिएगा कि कुछ इस तरह के नंबर्स आएंगे। इसमें जो पाई है हमारा, एक्चुअल में इसे हम 22/7 कहते हैं, लेकिन ये इरेशनल नंबर का एग्जाम्पल है, क्योंकि इसकी वैल्यू एग्जैक्ट 22/7 नहीं है। पाई एक इरेशनल नंबर माना गया। रूट के अंदर कोई भी नंबर ले लीजिए, 2 जो सर्ड्स होते हैं, 3, 5 जो सर्ड्स होते हैं, मतलब जिसका स्क्वायर रूट इसमें से बाहर नहीं निकलता। रूट 4 नहीं ले सकते। रूट 4 अगर लेंगे तो वो इसमें चला जाएगा, क्योंकि वो रूट से बाहर निकलकर 2 हो जाता है, और जो कि एक रैशनल नंबर है। जो रूट से बाहर नहीं निकल पा रहा है, रूट 2, रूट 3, रूट 5, पाई, even minus root 2, minus root 3 are some of the examples of numbers which cannot repeat, neither it can terminate, it will keep on coming. So those are expressed as irrational numbers. Now, how to represent these irrational numbers and rational numbers on the number line, that is later to be studied. But डिटेल में अभी हम रैशनल के अंदर ही जाने की कोशिश करते हैं। पहले हम लोग रैशनल नंबर्स के बारे में थोड़ा सा डिटेल में जाते हैं। रैशनल नंबर्स में हम कई बार देखते हैं कि यहाँ टर्मिनेटिंग भी हो सकता है रैशनल्स। अब टर्मिनेटिंग का क्या मतलब है, आई एम गोइंग टू टेल यू व्हाट इज टर्मिनेटिंग डेसिमल्स। एंड कोई कोई नंबर नॉन टर्मिनेटिंग भी हो सकता है। Now, what terminating and non-terminating means? Terminating means if you divide the numerator by the denominator of a rational number, the remainder will be 0. After some steps, remainder will be 0. If you divide the numerator by denominator of a rational number, for example, let us consider 3 upon 2, 5 upon 4, 1 upon 8, and check whether I am telling the thing that if you divide the numerator by denominator, the remainder will become 0, then it will be a terminating decimal. Let us divide it. You take this, divide by 2, 2 1s are 2, 1 is the remainder, put point here, and 0, 2 5s are 10, you are getting 1.5, and remainder becomes 0. Therefore, this 3 by 2 is a terminating decimal. Now, if you divide 5 by 4, 4 1s are 4, 1 is the remainder, put a point here, put a 0, 4 2s are 8, 2 is the remainder, put 0 here, 4 5s are 20. So you are getting remainder as 0. So in second case also I am finding that the remainder becomes 0. But if I divide 1 by 8, 1 is less, therefore I will put a point here, 8 1s are 8, 2 is the remainder, put a 0 here, 8 2s are 16, 4 is the remainder, put a 0 here, 8 5s are 40. So again you are finding remainder to be 0. In all these cases, you have learned that the numbers which I am giving you in the examples on dividing the numerator by denominator of these rational numbers, I am finding the remainder to be completely 0. So if remainder is 0 after division or after expressing it into decimals, you can say these are terminating decimals. So there are two types of rational numbers. One is terminating and the other is non-terminating. What do you mean by non-terminating? So if you divide the numerator by denominator, remainder will not become 0 and the number will repeat. So that is non-terminating repeating decimal. Non-terminating and repeating decimal. If you divide, this is the definition, practical definition, divide the numerator by denominator of a given rational number, the remainder will not become 0, will not be 0 and the result will repeat. Either one number can repeat or a period can repeat. Let us check the examples. So I'm taking the examples of these. 1 upon 3, 1 upon 7, 1 upon 9. Similarly, many more. And in next page, I'm showing you how it is non-terminating. 1 upon 3 means divide 1 by 3. So you're getting 1 is less than 3. So 0 here, put a point here, put 0 here. 3 3 ja 9, 1 0, 3 3 ja 9, 1 0, 3 3 ja 9. So what I'm observing that I will keep on dividing. Every time I'll get 0.3333333, and this will keep on repeating itself. So what people put for this, 3 and 1 bar should be here. This bar indicates that this 3 is repeating itself several times. So here the remainder is not equal to 0, and also either a single digit repeat or a number of digits repeat, that is called period repetition. For example, 1 upon 3, and if I write 3 upon 7, observe the pattern here. Divide 3 by 7. So it's a small number, so I'm putting a 0 here. 7 4 ja 28, 2 is here, 7 2 ja 14, 6 is here, 7 8 ja 56, 4 is here, 7 5 ja 35, 5 is here, 7 7 ja 49, 1 is here, 7 1 ja 7, and 3 is here. So from this place the sum is again going to repeat. Sum is again going to repeat. Again the same period will repeat. So if I write 3 upon 7, I am finding not only one digit to be repeating, a group of digits which is called period. A period is repeating. 428571, 428571. So it's just like a ringing tone, 428571, and so on. So it also never ends. So non-terminating and repeating. So what is repeating? Here the thing is repetition takes place in this period 42857. So what do? This time we put the whole bar over the periods of the numbers which is repeating. So this is called non-terminating repeating decimal, in which one is one digit repeating, here the period is repeating. So this is pure irrational and this is mixed irrational. So there are two examples which is clarifying that when you divide the numerator by denominator, you are going to get the remainder to be 0 and no repetition will take place. And in second case, you are going to find the remainder is not at all 0 and sometimes single digit repeats or a period repeats. That is called non-terminating decimal. So non-terminating and terminating are the part of rational numbers only. Rational numbers can be terminating if remainder is 0. Rational numbers can be non-terminating and repeating when the remainder is not 0 and the period repeats itself. So far I am concerned with this decimal. I am converting a fraction, you can say a rational number, into a decimal, a repeating decimal or non-repeating decimal. Sometimes opposite will be asked. You will be given this 0.3 bar and will be asked to convert it into a rational number. So that can be done. We'll learn the process later on how to convert this into rational numbers. Now rational and irrational is very clear to you. Rational numbers and irrational numbers are two parts of the real numbers. But in depth I am going to study rational numbers which has got two partition itself. One is terminating and other is non-terminating. These all are the place of division where we find on division, on expressing it into decimals. If it is going to have remainder 0, then we will say that this is a terminating decimal. And if we are not going to have remainder 0 and the number repeats itself, sometimes a single digit can repeat and sometimes a group of digits can repeat. Those are called non-terminating repeating decimals. That is also a part of rational numbers, and I have given you set of examples where it is terminating and where it is non-terminating. So these are terminating and non-terminating decimals, and later on we are going to study the thing in the next class. So let us finish this class here. Things will be studied in depth in several lectures on this rational and irrational numbers. This thing is very important for class 9th as well as for class 10th also. So the very basis is to be strong so that you can do the sums very easily. Without the concept, you are unable to solve the problems. So this is the last thing which I want to discuss today. Later on, some more interesting things will be studied in the next lecture. Thank you.